They say everything has an opposite, hot and cold, up and down, black and white. But when it comes to black holes, their opposites, the white holes, things get weird. While we have plenty of evidence for black holes, we've never seen a white hole, and many physicists say they can't even exist. So what are white holes? And can we make one? Well, a white hole is basically a black hole in reverse. A black hole is a region in space with gravity so strong not even light can escape its pull. Once something crosses a black hole's event horizon, it can never come back out again, not even light. And because nothing gets out, no information escapes either. That means once something disappears into a black hole, it's gone forever. Black holes are truly the end of the story. But white holes are different. You can never enter a white hole, just like you can never enter a black hole, but they only eject matter. There's no dark, mysterious interior to white holes. It's just an empty region of space surrounded by normal space from which stuff comes shooting out. Unlike black holes, white holes are also called open regions, because whatever is inside them can escape and affect the outside universe. The idea of white holes was first proposed in 1934 by physicist Carl Schwarzschild, who also found the first exact solution to Einstein's equations of general relativity that described black holes. However, black holes and white holes aren't his original ideas. They actually first appeared in a paper published 10 years earlier by the physicist David Hilbert. But unlike Schwarzschild, Hilbert didn't take his ideas further. Anyway, at first glance, the concept of a white hole seems paradoxical. How can you have a region from which stuff comes out without having a way for stuff to go in? But this apparent contradiction isn't all that surprising once you realize that space and time intertwined in a four-dimensional continuum are infinitely malleable. If you could somehow get a black hole to run in reverse, you'd end up with a white hole. In fact, mathematically, a white hole is the same thing as a black hole running backwards in time. This doesn't mean you could actually turn a black hole into a white hole, though. Just as you can't turn the tape of a movie projector around to rewind a scene already played, reversing time would require you to find a way to make new information out of nothing. This wouldn't just violate the conservation of information, it would also violate the conservation of entropy. On the other hand, if you start with a white hole, there's no such problem. The idea is that stuff just appears from nothing on the surface of the white hole. This may sound like science fiction, but it's actually what happens in black holes too. According to Hawking radiation, black holes aren't entirely black. They emit a thermal radiation due to quantum effects near the horizon. This means that black holes slowly evaporate over time, emitting light and other forms of radiation until they disappear completely. This evaporation process effectively creates new information from nothing, and it's why black holes aren't really the end of the story. But white holes don't evaporate. They just emit whatever they have on their surface. So from the perspective of the outside universe, a white hole behaves like a black hole that's been turned inside out. In 1968, Roger Penrose proved that black holes are actually mathematically identical to white holes. What distinguishes a black hole from a white hole is not the geometry of space-time, but the distribution of matter and energy. Unfortunately, it seems highly unlikely that white holes actually exist. They're often mentioned as possible explanations for gamma-ray bursts, for example, but this idea has been ruled out by observations. White holes might also play a role in some models of the early universe, but in all these cases, they're extremely short-lived and can't be detected anyway. In the end, while white holes may make for fun science videos and thought experiments, physicists seem to agree that they're just mathematical curiosities. No one has ever seen one, and no one ever will. So next time someone tells you everything has an opposite, make sure to tell them about white holes. They'll be impressed. They'll think you're so smart. Just make sure you know what a white hole is. Thanks for watching.